Hey guys, welcome back to the channel. In this video, we are going to discuss a problem on Nyquist plot. And in previous video, I have explained what is the procedure and it explained every basic of a Nyquist plot. So you can find that video in my channel and yeah, don't forget to watch that video also. You will get the exact basics of this Nyquist plot. So let's take one question for Nyquist plot, that is 50 by s plus 1 and s plus 2. This is the normal transfer function of a system and we are going to draw the Nyquist plot of this system. So as the first step says, we will draw a contour based on the number of poles. I mean the poles are lying on the origin or not. Here you can see that the pole is -1 and -2. There is no pole that is lying on the origin. So we will draw the contour like this. First it will start from origin and it will go to infinity. This is path C1 and from infinity plus infinity it will go to minus infinity, and this is called path C2, and this will go from minus infinity to again 0. This is C3. This is the first case where the pole of the zeros are not equal to 0. There is no pole which is located at the point 0. So we drew the contour like this: contour 1, contour 2 and contour 3. Now in the second step we are going to substitute s is equals to j omega, and we are going to see the separate the imaginary and real parts, and we will see at what point the curve is cutting the real or imaginary axis, right? So here we can see that the type of the system is 0 and the order of the system is 2. How to see the type and order? First, see how many s are there outside of this. If there is nothing addition to it or subtraction, then see how many s are there without addition and subtraction. There are no s with addition and subtraction on the outside. So we have wrote type is equals to 0, and see that how many s are with addition or subtraction. That is 1 and 2. So I wrote order 2. Now I will draw the diagram on basis of type and order. So the type always starts from 0 and the order always starts from 1. This is type 1, type 2, type 3, and from here order 2, order 3 and order 4. Fine. The basic diagram will come like so. As it is type 0, we started from infinity, and the order 2, so it will end at this corner. So I started from infinity and ended into order 2, and it went into 0, touched the 0. Now we are going to find this point of intersection which is on imaginary axis, right? So to get this imaginary axis, when we will separate the imaginary and real part from the equation, we will substitute the real part equal to 0. Real part equal to 0. So let's see how we can do that. So first of all, we will substitute s is equals to j omega into the given equation, that is j of s is equals to 50 by s plus 1 and s plus 2. So g of j omega will be equal to 5 by j omega plus 1 and j omega plus 2. Now we will calculate the magnitude. Magnitude will be equal to root of omega square plus 1 and root of omega square plus 4. And we'll also see that what is the phase. Then we can write the phase as minus tan inverse of omega and minus tan inverse of omega by 2, because after converting it into standard form, that is 1 plus j omega and 1 plus j omega by 2, this is j omega by 2, that's why we took omega by 2. Fine. And now we will separate the imaginary and real parts by rationalizing the equation. So this is the equation: 50 by 1 plus j omega and 2 plus j omega. We will rationalize it: 1 minus j omega and 2 minus j omega by 1 minus j omega and 2 minus j omega. So we got this equation, and if I separate the imaginary and real parts, 2 minus omega square is the real part, this is, and if this is done, this is the imaginary part, because it is having j. So if you want me to simplify more, I can do it like minus j, and this will become 150 omega 4 plus omega square. This is the real part and this is the imaginary part. So as I have said earlier that we have to find the point on the imaginary axis. So we are going to make this real part equal to 0. So when we equate it to 0, we'll get 2 minus omega square by 4 plus omega square equal to 0. Now as we will take this to 0, it will become 0, and this is 50. 2 minus omega square equal to 0. 50 cannot be equal to 0. So 2 minus omega square is equals to 0, and omega square is equals to 2, and omega is equals to root under 2. Now we got omega equal to root of 2. So we will substitute this in the magnitude to get the point of intersection on the imaginary axis. Our magnitude was 50 by root 1 plus omega square and root 4 plus omega square, right? So when we substitute the omega value, 1 plus 2, 4 plus 2. So see, I got 11.78, right? So this is 11.78. So this point, this distance is the distance from the origin to the point intersecting on this imaginary axis. This is the magnitude, that is 11.78 from the origin to the point on the intersecting on the imaginary axis. Now we will draw the contour for C2, and for that we will take this for contour C2. We will substitute S is equals to limit capital R tends to infinity R into e to the power j theta, and when we substitute this into the given equation, that is 50 by S plus 1 and S plus 2. So this will become S of, just leave it, we'll write normally. This will become limit capital R tends to 0, and this is R into e to power j theta plus 1 and R into e to power j theta plus 2. Okay. Now what we'll do is we will take this and this out from the brackets. So as R tends to infinity, this will become 1 by infinity. So it is 0, and also this will become 1 by infinity. This is 0. So when we substitute that equal to 0, we will get, and we will separate these terms as R square and e to the power 2j theta. This is 0 plus 1 and this is 0 plus 2. Now we will substitute this as infinity. So we will get 50 by, this is infinity, e to the power 2j theta, and here we got 2. So it will get cancelled. This is 25 into, this will get 0, and if we take this to the upside, it will become minus 2j theta. And this will get multiplied, and we will get 0 into e to the power 2j theta. Never do the mistake to multiply everything with 0 and convert it into 0. Do not do this thing, because this is the magnitude and this is the phase. So do this calculation carefully so that we will get finally a magnitude and a phase, and by using these two we will draw the C2 contour. So I'll show you how we can draw this. So we got magnitude as 0 and phase, that is e to the power 2j theta. So here for second contour, that is C2 path, the contour was coming from plus 90 degree to minus 90, right? So this theta is coming from plus 90 to minus 90. So here we are having minus 2j theta, right? Just remove that j, and when we will multiply this theta with this, we will get minus 180 to plus 180, because theta is lying from plus 90 to minus 90, right? So when we will multiply with 2 and minus, it will become from minus 180 to plus 180. So based on the magnitude and this phase, we will draw the C2 contour. That is from minus, right? This is first 0, then plus 90, then 180, then this is 270, again this is minus 360, minus 270, minus 180, and again minus 90. So this is from negative to positive, right? So when it goes from negative to positive, it will be in anti-clockwise direction. So as it is negative and going towards positive, first it will reach 0, and from 0 it will go to plus 180. So from minus 180 it will come to minus 90, and then it will go to 0, and from 0 it will go to plus 90, and then it will go to plus 180. So in the final diagram we will draw it as small as possible, because it is having magnitude equal to 0. That's all for C2. And for C3, it's damn easy. We will just take the mirror image or opposite image of C1. That's it. So C1 was looking like this, right? So we will take the mirror image. The mirror image will look like this, and it will go to infinity. the arrows should be coming towards 0. And this also, this magnitude is 11.78. This is real axis, this is imaginary axis. So you can see that the distance from 0 to the minus j omega is also same magnitude, and from this also it should be same. Fine. And finally we will draw the entire 3 contours, that is C1, C2 and C3 in one diagram. So take an imaginary and real axis. So C1 is like this, it's coming into the origin from infinity. C2 is like this, and C3 is coming from minus 180 degree to minus 90, 0, then plus 90 and plus 180, and also draw the arrows. And since it is having magnitude 0, I drew it in small manner. This is the final Nyquist plot of our given system, that is 50 by s plus 1 and s plus 2. That's it, as simple as it is. So I'll just give a review on this. First step is to draw the contour based on the poles. If a pole is not there at the origin, it will have only 3 contours, that is C1, C2 and C3. If there is a pole at 0, it will have 4 contours. And in step 2, for drawing C1, we will see the order and type of the given system. So here we got type 0 and order 2. So it started from type 0 and ended into order 2. After this, we are going to substitute s equal to j omega, and we will separate the imaginary and real parts. This is real part and imaginary part. And based on the axis on which this diagram is intersecting, we will make that part equal to 0. Because here the diagram is intersecting the imaginary axis, we have put the real axis equal to 0. And whatever the omega value we got, we substituted into magnitude, and we got the distance of that intersecting point from origin. And for C2, we substituted s is equals to limit capital R tends to infinity into r into e to power j theta. And do this calculation carefully, because we are going to get magnitude and phase in last. As we got the magnitude and phase, we will draw again the C2 contour. Phase is from minus 180 to plus 180. So we will start from minus 180, then minus 90, then 0, then plus 90, and then plus 180. And for C3, this is the easiest part. Just draw the mirror image of C1. And finally, as we are having just 3 contours, that is C1, C2 and C3, we will not go for C4 calculation. And finally, we will draw the last diagram, which is Nyquist plot of the given system. Kindly draw this with pencil. Yeah, that's it for this video. If you liked it and understood the concepts clearly, then don't forget to click that like button and also subscribe to my channel right now. And also don't forget to see the basics of this Nyquist plot. And also I have made a video on root locus. You can check that video on my channel. So that's it for this video, guys. Thanks for watching. Bye.